So let's look at a few more examples of optimization and finding the max and mins. So the demand equation for a certain commodity is this equation P. And they said, these are my bounds between 0 and 60. And it says, find the value of X and the corresponding price P that maximizes the revenue. Okay, so we're trying to maximize the revenue, which means I need an equation for the revenue. So we know that the revenue is X times P. So that's what we're going to do. We're going to do X times our function P. And because I don't want to do product rule, I mean, you're welcome to, but it takes longer. We're going to distribute to make this a little bit easier to take the derivative of. And then this is my revenue function. So if we want to maximize or minimize, the process is we always take the derivative and set it equal to 0. So I have 1/12 times the 3x squared. I have the 10 times 2x plus 300. So 3/12 reduces to 1/4. And then 10 times 2 is 20x plus 300. Okay, so this is my derivative. I am going to set this equal to 0 to find where this occurs. Okay, and you have two options. You could do the quadratic formula or you can factor. Now, because this is equation and it has a fraction, it's usually easier to get rid of the fraction. And as long as you have an equation, you can do this. You can multiply everything by what's in the denominator. So you can multiply everything by 4. So if you multiply 4 times 1/4 x squared, you're getting like 4/4, which is just 1x squared. 4 times negative 20x is negative 80x. 4 times 300 is 1200, and then 4 times 0 is 0. So I'm multiplying every single term by 4, and because it's equation, I'm not changing the values of x. Then I could factor this. So when we factor, we're going to figure out what multiplies to 1200 and adds up to negative 80. Okay, again, if you don't like to factor, you could do quadratic formula. So I think about 12, that's 3 and 4. So the options would be like 30 and 40, but they both have to be negative in order to get a negative 80. So if I do negative 30 plus negative 40, that's negative 70. So that doesn't work. I could try 60 and negative 20. Again, they both have to be negative, so that multiplies to a positive. If I do that, I do get negative 80. So this factors to x minus 60 and x minus 20. We set each factor equal to 0. So x is 60 and x is 20. Okay, so those are my two possibilities. Now we need to figure out which one is a max and also make sure they're in our domain. So this is my domain. So they both fall in that domain. So we need to figure out which one is a max. And we also, because our interval was 0, technically 60 could also be a max. It wouldn't make sense, but it could, is the potential to be a max. So we should check all these values. Because we have endpoints, usually the best way to check it is to do the first derivative test instead of the second, because you can't check an endpoint with the second derivative test. So I'm going to put my 2 critical points, which are these, and then the endpoint. So one of the critical points is an endpoint. And then I'm going to do test points in each area into the derivative. So I'm going to try like 10 because that's in this interval and 30 for this one. So I plug these values into the derivative. I guess I should say R and R prime because we're doing R. Okay, now for this one though, you cannot plug it into this. Okay, that was what we were doing to solve our equation. That is not the equation for R prime. So we need to plug it into this one here. So we're gonna plug our test points into our derivative. So I'm gonna plug it 10 into this and 30 into this and then simplify. I'm just gonna do this in my calculator. So I'm plugging everywhere I see X, I'm substituting in 10. So we get 125. So this is positive, which means F is increasing. So that's gonna mean this endpoint of 0 is a min. If I plug in 30, oh, sorry, I wrote this wrong. 20 times 30. I get negative 75. Okay, so that means it's decreasing on this interval. It's negative, so it's decreasing, which means 20 is a max and 60 is going to be a min. So my max is occurring at X equals 20. And then just go back to the question and make sure you answer all of it. So it says, find the value of X, we did that, and the corresponding price P. So this is my P. I need to multiply. I need to plug in X into that to get my P, because we want that. So P is 1/12 X squared minus 10X plus 300. So I'm going to plug in 20 into that. Okay, and I get the price, we'll do 2 decimal places because we're talking about money, is 133.33. And so that's another example of maximizing with a revenue cost or profit function.